Hey class, welcome to our 2.1 video on distance and displacement. Now, before we dive into what these two things are, we actually have to talk about something else that will lead into the rest of this unit and honestly the rest of the year. So let's start by talking about scalars and vectors. So the reason we have to talk about this is because distance is one of these and displacement is also one of these. So scalars versus vectors. And let's get their definitions first. So a scalar is basically any number. It's just a quantity. A quantity is a fancy word for number. So it's a quantity with only a value. Now, why is that important? Well, there's a lot of things that might be a scalar quantity. So some examples would just be any sort of length. So like 5 meters. That's a scalar because it's just a number. We might have something like 12 liters. So again, it's just a value. It's still important. It's a number, but it's just a value. Maybe the mass of something. So like 23.4 kilograms. That's one. Or honestly, you know, those crazy people in those math problems, I've got 200 apples. That's just a scalar. It's just a number value for something. So it gives us important information, but there's something that gives us more information that ends up kind of being important here in physics, and that's a vector value. So a vector is like a scalar with a little added information. So it is also a quantity. Again, that's just a fancy math term for number, with a value and direction. Now, why is direction important? Well, here in physics, direction is going to start being positive and negative. So positive being forward in our point of view and negative being backwards from our point of view. Instead of, in math, negative means like the absence of something. Today, we're going to have to start shifting that perspective to it just means the direction. So some examples of this might be, that 5 meters, but instead it's 5 meters north. Tells me exactly where I'm going. Or maybe a speed, so maybe 18 meters per second to the left. Doesn't have to be a compass rose direction. Or another one is 26.2 kilometers west. Now, some ways we might represent these. So a vector, an easy way to think about a vector is that it is an arrow. It starts somewhere and it's going in a direction, as opposed to a scalar can be represented just by a line. A line can exist anywhere. It can go in any direction, but an arrow, as soon as you move that arrowhead, you're changing information. You're pointing in a different direction. But a line is just a line. So it's a good way to think about those. Now, when we think about that positive versus negative that I talked about, we have to think, okay, what is our generality direction? So if you are going up or you are going right, these are going to be our implied positive directions. So, or on a compass rose, that might be north or east, might also be what we say. And that is just our generalized direction. So north or up, east or right is positive. Now you can change that and we'll talk about that as we move forward. But right now we just want to talk about that up and right are going to be our directions. So just remember that as we move forward. So if you got a handle on what a scalar and a vector is, now it's time to move and actually apply this to distance and displacement. So we're going to scroll this down a little bit. And now it's time to talk about distance versus displacement, the thing we actually came here to talk about today. And you'll see why scalar and vector is important to talk about. So, again, we're going to define these separately from one another. So we're going to start with distance. So distance is the total length of the path taken. So let's, for example, I'm going to draw a little thing down here. So let's say that I am going for a little run. I'm on a trail, so my trail's real windy, right? I'm going to go back maybe over a bridge, and I'm going to end up over here. And let's say this person did a total distance of 30 meters. So that's the path it took him. And notice it's just kind of all over the place, right? And that shows us, first off, distance is represented by a lowercase d, and it's measured in meters. So he ran 30 meters. He ran in a loop and went around and came back around. Well, that's a little bit different from displacement. Because for displacement is simply the change in position. And that's going to be represented by delta x. Delta means change in, and x means position. So when I'm talking about my displacement, let me get a different color here for us. For delta x, I don't care about all the wiggly wobblies of this guy. What I care about is where I started and where I ended, which is over here. And it's clearly going to be shorter than. So again, we said this was 30 meters. So we'd probably say this might be closer to like 10 meters. And I have to say 10 meters right, because that's the direction I ended up in. So as you can see, it's usually going to be equal or shorter than, but it depends on where you started and where you stopped. That's the important part, where you started versus where you stop. So let's go ahead and look at some examples here of what you're going to be asked to do when it comes to this. So we're going to look at some practice. So first, we're going to look at two different practice problems today. So we're going to have an object travels 5 meters south and 12 meters north. Our goal is to find, actually let's do that in a different color so we can do these separately. So first we're going to find D, and then we're going to find delta x. So I'm going to start by drawing a picture of what happens here, and then we'll be able to hopefully better figure out these two things. So first, my object, I'll come over here, it goes 5 meters south. So I'm going to draw a southward arrow going down, that's 5 meters, and then it goes, well, 12 meters north. So I'm trying to find D. Again, D is just the total distance traveled. So I'm going to go, he went 5 meters south, then he went 12 meters north, and that'll give me 17 meters. Well, that was easy, right? You just add up all the arrows, 17 meters. But displacement's a little bit harder because, again, I have to think about the change in my position. So displacement really is just this arrow here, but how can I find that? Well, I can add up the arrows, but in thinking, remember, up and to the right is positive. So my 5 is actually a negative 5 meters plus that 12 meters up. And if I did that math, I would end up actually with 7 meters. And if you think about it, well, I went down 5, I covered that 5 back up, and then went 7. So yeah, that makes sense. I end up 7 meters positive. Now, I am missing a bit of information here. I need to mark where I am. So I'm actually 7 meters north. Don't forget to mark that direction. That's important. All right, let's do one more. This one might be a little bit trickier. It's our second practice here. We're going to look at a person. This person's going for a little walk. Walks 50 meters north. $20 meters east, 50 meters south, and 20 meters west. And we're going to do the same thing. First, we're going to find distance, and then we're going to find displacement, or delta x. So let's draw our picture of what this guy's doing. So he goes 50 meters north. So I'm going to draw an arrow here. That's 50 meters. I know I'm going east next. That's why I wrote on the left side. So then I'm going to go 20 meters this way. And then I'm going to go 50 meters south. And I'm going to go 20 meters west. And if you're catching on, you might have figured out already what our things are going to be. So if I look at my distance, as we talked about, distance is just adding them all up. So I went 50, and then 20, and then 50 more, and then 20 more meters, which gives me a whopping total of 140 meters. Box in my answer, which is great. I love that. Now, delta x is a little bit trickier because if you notice, I started and then ended up in the exact same spot. So you would be able to denote here that your displacement is 0. Now, you might go, well, hold on a second, Mr. Clark. I traveled. I went somewhere. But that's all about the change in your position, which in this case is 0, is going to be that change in position. So I hope this has given you a pretty good understanding of distance and displacement. You've got worksheet 2.1 that you can go start on. It's about 7 questions over this that you need to go and complete before class. So thank you for watching, and I hope you learned something.